In this video, we will look at the solution for exercise 2, question 1 and 2. Let's start with question number 1. Solve the inequalities for modulus 3p minus 4 greater or equals to 2p plus 1. Give your answer in interval notation. So as you all know, this is absolute value inequalities. So actually we have two methods to solve this question. I will show you both methods. So let's start with method 1. So for method 1, as we all know, if modulus of x is greater or equals to a, then x is greater or equals to positive a, or x is less than or equals to negative a. So we will use this concept to apply in this question. So based on this question, modulus of 3p, since the modulus of 3p minus 4 is greater or equals to 2p plus 1. So 3p minus 4 is greater or equals to 2p plus 1, or 3p minus 4 is less than or equals to, we'll put a negative, but be careful, we need to put a bracket, 2p plus 1. So we try to solve these inequalities. You can see that now this is linear inequalities. So we can just solve it by moving the p. So next step, it will be 3p minus 2p is greater or equals to 1 plus 4. Means that I move positive 2p to the left hand side to become negative 2p, negative 4 to the right hand side. So this here is p is greater or equals than 5. From here, 3p minus 4 less than or equals to, here is negative 2p minus 1. So again, I move negative 2p to the right hand side, negative 4 to the right hand side. So what we have here is 3p plus 2p is less than or equals to negative 1 plus 4. So here will be 5p less than or equals to negative 1 plus 4 is 3. So p less than or equals to 3 over 5. So from here, give your answer in interval notation. So the question requests us to give the answer in interval notation. So interval notation. So interval notation. For the first part, p is less than or equals to 3 over 5. So it's getting smaller and smaller until negative infinity. So from here, the first part will be negative infinity until 3 over 5. And 3 over 5 is included. Union. This is p greater or equals than 5 or equals to 5. So p is included. So 5 is included. So 5 until infinity. So this is method number 1 by using this theorem. So we can solve, and this is the answer. Next, I will show you the second method. Let's say using the same question. Now I try to use method 2. So for method 2, from modulus of x, we can change to square root of x squared. Means that the modulus we can change to square root of x squared. Same thing happened here. So modulus of 3p minus 4 is greater or equals to 2p plus 1. So from this modulus, we will change to square root. Let's say using the different color, square. So here is 3p minus 4 greater or equals to 2p plus 1. So from the square root, how are we going to eliminate the square root? So what should we do is we try to, let's say, put a green color, square. So when you square when the power of 2 for left hand side, right hand side we also have to square. So from here, square root squared, we can cancel out. So on our left hand side will be 3p minus 4 squared. And our right hand side will be 2p plus 1 squared. Then we try to expand. So you can expand 1 by 1, or straightforward I can have 9p squared minus 24p plus 16 greater or equals to 4p squared plus 4p plus 1. So from here you can see that now this will become quadratic inequalities. Why quadratic? Because we have square. So because here we have square, p power of 2, the highest degree is power of 2. So that's why the higher degree is 2, so this is quadratic inequalities. If you still remember, for quadratic inequalities, one side must be 0. So from here, I will move all the term to the left hand side. So 9p squared minus 4p squared, here is 5p squared. Negative 24p, here minus 4p, now will become negative 28p. Then 16 minus 1 is positive 15. So it's greater or equals to 0. Next, we try to factorize. So here we have 5p. So here we have p. Let's say here is 5. Here is 3. In order to get negative 15, 25, 20. So here is negative. Here is negative. Greater or equals to 0. Remember, for quadratic inequalities, we need to use table in order to get the answer. So next, we will try to find the critical value. How are we going to find the critical value? By letting this bracket equals to 0. So 5p minus 3 is equals to 0. P will be equals to 3 over 5. Or p minus 5 is equals to 0. P is equals to 5. Next is the critical line. So critical line, the purpose of critical line is to determine how many intervals that we need. So now we have two values. One is 3 over 5. Another one is 5. So we need 3 intervals. So next, we will construct the table. So if you still remember, for table, we need 3 columns and 4 rows. So the first column will be interval. Second column is test value. The third column is sign of, where our inequalities is 5p minus 3, p minus 5 must be greater or equals to 0. So the first interval is from negative infinity until 3 over 5. So 3 over 5 here is included. So included supposed to be a square bracket. The second interval is 3 over 5 until 5. Final interval will be 5 until infinity. You might ask, when should we change to a round bracket? Remember, this is quadratic inequalities. From square bracket, when we change to round bracket is only happen to rational inequalities and only happen to the denominator. For quadratic inequalities, we just follow the square matrix, square bracket based on the question. So now the test value. So here let's say I put 0. Against the test value must come from the interval. So you have to be careful in this part. So second interval, let's say 3. Third interval, let's say 10. So next I will substitute into P. 5 times 0. This is minus 3, so it's negative. You just take the sign. P0 minus 5 is negative. So here is positive. Substitute 3. 5 times 3, 15 minus 3, 12 is positive. 3 minus 5 is negative 2, so here is negative. Here we should have negative. Finally, 10. 10, 50 minus 3, 47 is positive. 10 minus 5 is 5 is positive, so here is positive. So what should we choose? Is positive or negative? How are we going to determine? So we are going to determine by the sign. So this is greater or equals to 0. Means that we need positive. So positive means that our answer is here and here. Finally, the answer is in interval notation. So interval notation. So the answer will be negative infinity until 5/3 or 5 until positive infinity. So you can compare with the method 1 and we have the same answer. Now we look at question 2, which involves complex numbers. Given z1 is equals to 3 minus 3i and z2 is equals to 3 plus 2i. Express conjugate of I cube or I power of 3 over conjugate of z1 and z2 times z2 in the form of a plus bi. Means that from this division of complex numbers or rational complex numbers, we need to change into standard form. We need to turn into standard form. So first, what we should do is we try to reduce I power of 3. So from here, I power of 3. So first we need to know that this is odd index. So for odd index, we have the method to reduce the I or to reduce the index. So I power of 3, we can change to I times I squared. Where our I squared, you have to remember, is negative 1. So I times negative 1 is negative I. So conjugate of I cube, suppose is conjugate of negative I. So conjugate of negative I will become positive I. So again, conjugate of negative I is positive I. You might ask why. So you can see, I can show you example. Let's say, let's say given, let's say z is equals to, for example, negative I. I use this example, negative I. So from this z, actually I can change to z also equals to 0 minus I. I can put a 0 in front. So conjugate of z, suppose is 0 plus I. Or we can write as I. So if z is negative I, conjugate of z is positive I. Same thing happen here. Conjugate of I cube is conjugate of negative I. So conjugate of negative I is positive I. So next, you have to show this step. So next, conjugate of I cube over conjugate of z1, z2 also equals to conjugate of I cube is I. So I straightforward, I change to I here, over conjugate of Z1. So Z1 is 3 minus 3i. So conjugate of Z1 is 3 plus 3i times Z2. Z2 is 3 plus 2i. So next, I will expand the denominator. So I over 3 times 3, 9. 3 times 2i, 6i. 3i times 3, 9i. And finally, 3i times 2i, 6i squared. Next, I try to simplify. I over 9 plus 15i plus 6i squared is negative 1. So next, I over 9 plus 15i minus 6. 6 times negative 1 is negative 6. So here is I over 9 minus 6 is positive 3 plus 15i. So this one also still in rational form or division of complex numbers. Next, we should multiply with the conjugate of denominator. I multiply with the conjugate of denominator. So now the denominator is 3 plus 15i. So the conjugate of 3 plus 15i will be 3 minus 15i. Same as the numerator, 3 minus 15i. So when I try to expand, here the numerator is I times 3 minus 15i over the denominator will be 3 times 3, 9. 3 times negative 15i, negative 45i. 15i times 3, positive 45i. Finally, 15i times negative 15i is negative 225i squared. So the numerator, I times 3, 3i, minus I times 15i, 15i squared, over 9. For the conjugate, here we can cancel out negative 45i plus 45i. So here we have minus 225i squared, again is negative 1. Same as the numerator, I squared is negative 1 over 9 minus 225 negative 1. So from here, 3i plus 15, 3i plus 15 over 9 plus 225. So here is 3i plus 15. 9 plus 225 will be 234. So next, we try to separate into two parts. 15. So for constant, we put in front 15 over 234 plus 3 over 234i. When I try to simplify, you can use your calculator to simplify by type in 15 over 234. 15 over 234. Here suppose is 5 over 78 plus 3 over 234 will be 1 over 78i. So here is the standard form. So means that based on this question, first what we should do is we try to reduce the index of I. So after reduce the index of I, we will try to simplify. And then in order to change into standard form, we need to multiply with conjugate. So after that, you just expand and simplify, and here is the answer. 5 over 78 plus 1 over 78i. So here is the standard form of complex numbers.